Dear students, in this video, we'll learn about pair of linear equations in two variables, a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. Yes, you observe children, the coefficient of x in the first equation is a1, coefficient of y is b1 and the constant in the first equation is c1. Let us consider the coefficient of x in the second equation, it is a2. The coefficient of y is b2 and the constant is c2. Let us try to find out the relation between the ratio of the coefficients, which we have just seen, and the nature of system of equations today. Consider the linear equation 2x plus 3y minus 4 is equal to 0. It is a straight line. Now let us just note down the coefficient of x. Here in this case it is 2. The coefficient of y is 3 and the constant here for this equation is minus 4. C1 is minus 4. Let us try to change the values of a1, b1 and c1 and observe the change in the line. You can see the values of a1 are changed now and you can see the reflection, the corresponding change in the straight line. As we are dealing with the pair of straight lines, pair of linear equations, let us consider one more linear equation. You can see a line red in color whose equation is 4x plus y plus 3 is equal to 0. Let us note down the coefficients. a2, here in this case it is 4, b2 is 1 and the constant in the second equation is 3. Now we'll just try to change these values a1, b1, c1 and a2, b2, c2 and try to see what happens to the lines. Now you just observe the values of a2 are being changed. When a1 is 5 and a2 is 10, you can observe both the lines are intersecting. I'm just changing the values of b2 right now and b1. Yes. So you can observe children, when the values of a1 is 5 and b1 is 2 and c1 is minus 6 in this case right now, and for the second equation a2 is 10, that is 2 times that of a1, and b2 that is 2 times that of b1 here in this case. So what do you observe? You can see the lines are parallel right now. You can observe that the lines are parallel. So let us just note down the ratio of this coefficients a1 by a2, that is 5 by 10, which is 0.5 in this case, and let us even note down the ratio of b1 by b2, which is also 0.5. So let us check the ratio of c1 and c2. So here it is c1 by c2 is minus 2. What do you observe children? a1 by a2 is same as b1 by b2, but the ratio c1 by c2 is different from these two. So in this case, we can observe that the lines are parallel. Let us try to change the ratio C1 by C2 also as 0.5. For that, let me change the values of C1 and C2. So let us make C1 some 3, and now we should have C2 as 2 times of 3, that is 6. Let us change and see that. Yes, you can observe that the ratio C1 by C2 is also equal to the other two ratios right now. All the three have 0.5 as a ratio of the coefficients. Now, what do you observe in the graph? Right now, you can see only one line. What about the other line? We are considering a pair of linear equations. So, what happened to the other line? Let us just see. Okay, we can see that the two lines are coincident, one overlapping. You can observe when I'm just moving C2, the values of C2 are changed. You can see that the lines are separate two different lines, but when this ratio C1 by C2 coincides with the ratio becomes equal with the ratios of A1 by A2 and B1 by B2, you can observe that the lines are coincident. That is, the two lines are one over the other, overlapping. So we can say that when the ratio A1 by A2 is equal to B1 by B2, which is also equal to C1 by C2, then the lines are coincident. And when this ratio, the third ratio, C1 by C2 is different from A1 by A2 and B1 by B2, then you can observe that the lines are parallel. That is, to check whether the two lines are parallel, it's enough if we can observe, we can just check A1 by A2, B1 by B2 and C1 by C2. If the first two are equal and not equal to C1 by C2, then the lines are parallel. And if all the three ratios are equal, then the lines are coincident. Now let us see if the A1 by A2 is not equal to B1 by B2, what happens to our lines? Yes, now you can observe A1 by A2 is 0.5 and B1 by B2 is -2. These two ratios are not equal. So when they are not equal, what do you observe in the nature of the system of equations? Yes, they are intersecting. The two lines are intersecting. So let us just try to see if C1 by C2 is equal to one of these two values. Do we see any change? Just let us see, let us observe. Yes, now B1 by B2 and C1 by C2 are equal. Even then, the lines are intersecting. That is, irrespective of the ratio C1 by C2, we do observe that when A1 by A2 is not equal to B1 by B2, the lines are intersecting. So we can say that children, when the ratio A1 by A2 is not equal to B1 by B2, irrespective of C1 by C2, the lines are intersecting. And when A1 by A2 is equal to B1 by B2, the lines are parallel. You can observe the lines are parallel. And when this ratio is also equal to C1 by C2, you can see that the lines are coincident. That's all for today, children.